with Revas on tree-valued logic. And I hope we can continue to work with Ramas and his team. So we're a little bit short on time. So if you want to ask questions or discussions, please email Johan. Now, I have a bit of ideas. I'm going to organize a few smaller sessions later after New Year with potential collaborations. So I will set this up later. Now, the next speaker is dear friend Matthew He from Florida. He is currently in San Francisco. Of course, I don't know where he is. He was on a holiday. So, and he will talk about the special topic, which is called geometry. So, and I have one question, Matthew. Can you try to present yourself, or do I present your?
Let me try. See if it should work.
Yes.
Yeah.
Okay.
Let me see here. All right. Are you able to see it?
Yes. If you can go to full screen, that would be. Yes.
Yeah. Okay. Really want to thank you, Johan, for having me. And I'm not in San Francisco Bay, but in the Caribbean Sea. I'm on a cruise. Yes. Yeah. We are our winter break, and so currently we are in the middle of the sea and go to the Belize. So this is about the 9 o'clock here, and I guess you guys are what
now
time you have there?
3.3.
All right, I will try to finish within my time frame, and so I want to mention this to you here that in last year you had me to present some lectures. I ended with this particular shape of the word. Read as yao, the very top. So that was a word that I ended my lecture back in the Issbg 2024. So that is a special word inspired by our conversation back in 2023 when I was in your Gilead's Geometry Garden in Belgium. You had me and Paulo inside of that garden. So we were chatting, talking, and you talked about square bamboo. So turn the geometry from the geology into the bamboo geometry. So that was a wonderful inspiration. So instead of fixed elements, and it becomes a continuous transformation. Particularly recently, we are discussing your recent work on the ultra points, the point manifold, which is tremendous work over there. I think that can be applied in many domains, open a new door for many directions. In particular, I'm thinking that today when Marisa talked about her work on the genes and the fruit fly, and that can be use a ultra point to describe. Look at the shape of that, the fly dragons and the fruit fly. I think that's a good the interaction already here. Also, today when I hear the Julius lecture about the mobile's transformation, and so that was inspiring, particularly when he mentioned those 8 color functions. So what's reminding me that in classical trigonometry, we have a sine function, cosine function, trig function, and cotangent function. So 4 base functions open the trigonometry. So now here's the 8 functions. If they are all independent or paired in some way, may becomes a new kind of a geometry in 3 dimensions, describe all different shapes of 3-dimensional objects. So that was very inspiring. And also the word I heard about today in your lecture yesterday, Yuhan, you mentioned the information conservation. So information is conserved, energy is conserved, and today when Marisa mentioned that DNA shapes is conserved as well, which is a very deep result there. So my talk is about idea. So there's a wonderful ideas we are talking about. So my question here is asking myself, what is idea? Where that comes from? And what shape and form of idea is? Is idea conserved? So those are fundamental questions that reminds me this particular word of yao. So let me begin with this spatial character and 4 strikes. It's a 4 strikes. So you can see that shape go from the left, go from the right, that's on the top, and the bottom, go like that. So, and also see that when we do our gesture, we do this, we do this, and we do this, or we do that. So it becomes all different shape of our transformation. So we do all that. So I saw Yuhan was doing this. And I see also you do this sometimes. So we shake hands, we do our gestures. All those emotions are captured in some ways that we may just automatically do it. And also, when we look at nature, we look at the trees, look at forests, oceans, mountains, all that things there. And particularly, one was saying that we see the leaves, everything sort of leaves. Now, this little word here, this very old word, in fact, if you look at its the history and the evolution, it grows as well. It's almost like a leaf from our idea came into the shape. So this word has a spatial meaning in the ancient Chinese book, the I Ching. I guess you heard about the book I Ching. It's a book of change. So this is a very special word embedded inside that book. Our modern book of change is a calculus. We look at all the calculus nature, look at the derivative integrations, look at all the changes here. So this is a word that going through from very ancient dynasty and evolve, you grow, you give different shape or forms. However, the basic structure remains over there with the 4 strikes. 4 strikes. So using those 4 strikes, you can capture all different pair using some, for example, DNA is 4 nucleotides, ACGT, and we have 4 color problems. And we look at the nature force. There's 4 basic forces. So this can become an interesting domain from language perspective. Look at how this language grows, and look at this living geometry, not just a geometry, it's a living geometry that I give this name of it. So this little history there, those are characters are representing different dynasty, and this is what's currently we have now. So this is the basic shape of it. If you look at it from a geometry perspective, it's like 2 axes. 2 axes are wrinkled together. The one thing is that they have intersection. So now, when I mentioned this word to Yuhan, he point me to the particular, hold on, let me do this one first. And this particular shape of the quincunx from Sir Thomas Browne and the Garden of Cyrus. So this is from a simple word of X, which if you look at the nodes, is 5 points. Those 5 points are connected very elegantly. You got the 4 corners and with the center in the middle. So when you make a connection, now you see this beautiful garden. When you look at our nature, no matter where we go, so you're going to see this kind of shape in the architecture, in the art, in the every places here. So this was a quite bit of connection. When I see this here, then I look at this particular character, the I Ching. So not just say the points, you got a connection. Now, those connections looks like strikes. Those strikes can be straight, can be curved, can be all different shapes. It's not just a strike first. It can be just say the philosophy of it. It captures the closeness and openness. It captures the intersection, captures the separation. So all those things can be captured by this little symbol here. So historically, this word is from ancient Chinese ideogram and known as the rule in I Ching, as I mentioned earlier. And however, back then, the recognition of this word was limited. So kind of symbolized that as only two states of a solid line and a broken line. When it's a solid, it's yang. When it's a broken, it's yin. So it's a binary indicator at that time. So it becomes a structure. So it becomes a kind of an early function. So without recognizing that's a function we recognize today, but that was time was just say simply yin and yang. One is a solid, one is a broken. So these two symbols evolved into the 64 hexagrams. So that was idea back then. So then this a 64 guys was arranged into two spatial shapes, one perfect square inside and one circle outside. So the square it becomes our modern matrix. It's an 8 by 8 matrix. And now you have this shape here. What is also interesting, this particular I Ching shape of 64 hexagrams was also captured by Leibniz back in 1701. That was over 300 years ago. He kept this work here while he was working ideas of calculus. So this kind of give me the shape of a circle, square, and also the binary indicator, and which lead you to a general philosophy how to deal with the nature of that. So this was interesting. Learning for me is that there was back then there was exchange a idea of this development of these symbols here. So now this is the one that Johan mentioned that to me with this X. So the X is a wonderful letter. In fact, as you know, in Greek letter we have a chi. Chi is a very special shape with a crossing and with the 5 points in the corner and the center. So this gives us a fundamental units of that. So in I Ching, this little shape, in fact, being viewed as a network of the universe. So that's what they're saying. It basically captures the intersection and the separation, and all these philosophical definitions can be displayed from this shape here. So if you look at some of the crisscross network, you can see the different shapes of images over here, and they all resemble the motifs of Yao. And whichever you see, even today, whenever I go to a park, I look at the trees, look at some of the buildings architecture. If you try to zoom in, and you're going to see this word Yao appears over there. So that is some examples I'm showing here. And if you look at further about today's artificial intelligence, dealing with the recent technology, the TPU. So the currently GPUs are very popular, dealing with all the AI calculations and generation. Recently Google came out a TCU, the T represents a tensor. So tensor idea is part of deep learning. And when you look at this, the logical behind that things that you quickly see the spatial motifs of Yao is within. So that is a kind of a reflecting also the axiom Johan defined the two axioms. One is the distinguishability, the other is connectedness, and so this little word, very special word, capture all that nature of this networking. And if you look at further in terms of biology and human thoughts, you see that even though if you look at the structure of a double helix, that give me the characters of Yao in it. And if you look at the particular nervous cell, and also give me that kind of a feel what Yao will play inside our brain. So the one of the picture here, the middle one, bottom one, so that is capturing the two sides of logic, the binary and fuzzy logic, and there's an intersection in the middle. So that's how oftentimes I call it thinking kernel, so where the sparks are taking place. So you have that intersection. So intersection is important because without intersection, there's nothing come out of it. So it's what's intersection? It's our mathematical zeros. So zero, when you find the zeros of some functions, you find an intersection. So that is a crucial for our understanding of those natural phenomena. So simply, if you look at this a little description, I can use a simple function of absolute value of x and capture this character of Yao. So they are flipped down, so you have this shape here. So you can certainly do a quick generalization to different shapes, different variations. You can expand it and you can make a curve it. So it's a basic things, can do so many things over there. So that is some of the variations and extensions of this particular word Yao. And so come back to my question. I have been struggling to keep me awake, even at sea, always thinking about, so what is idea, where that come from? So this Yao is Asian idea still remains strong and reflected by modern science here. So, and also when I hear the Johan mention that we want to see what's here and what's not there. So, our brain is an interesting mixture. It's here and there, so we are covered between individual and the general. So every thought has its own mathematical abstraction. So some of the things that we continue to explore. So what really this brain, what this organ does to us. So the following four fundamental questions has been our driving force from matter, inorganic, to life, organic, and then to current. Well, in fact, the information is there, so we want to continue to discover. And then again, so what is the mind? So those are the questions. So so when we look at the mind, we look at the body and brain. Look at this, particularly from a neurobiology perspective, or look at the structure of these neurons, or see the structure, see the shape. So I was looking into the shapes and the forms. So to me, the idea comprises of three things: the numbers in it, shapes in it, and the relations in it. So if you look at ourselves, this is like a Yao here. All right. So if you look at our brain, if you look at the forest of trees, we are sort of a forest in our brain. And the left side is a forest tree, or the right side is the image of our brain nerve system. And if you zoom into the details, you got all those wonderful neurons images, so we can try to simulate on that. So these geometries are starting emerging in my mind. Looking at. So this is a early slides I had. Look at different two major logics, binary and fuzzy. So I call it fuzzinary logic. In fact, when we think, we have a process in our brain, and also we have a point we make a decision. When we make decision, is where we have action potential, either yes or no, or all or nothing. So that's the states where we make decision. And now, before we make decision, we don't spark. We kind of have a resting area. We have a graded area. So we do all those other kinds of potentials in our brain. Do that. So this is a reflection. We try to see inside from outside. So then this is the picture that enjoy much about it. The Yuhan mentioned that the middle one particularly, that is where the continuous transformation and the origin of that is a Pythagorean. And so this continued to become our geometric language for that, but we extend it through the latest developments of the geometry. The geometry is not just geometry; it's some moving, living, and it's live. It's organic type. So if you look at today's structure of our artificial system, it is a self-organizing system. It's sort of a global brains with all different nodes that connect, they separate, they connect, they separate, become a whole system. So this is one of the slides I always enjoy to have. It is published in the Nature from Notre Dame group of people doing the biology and the bioinformatics. So they're making try to capture our that 3-pound brain is working. So towards the end, I want to conclude with this special character with these 4 strokes with the new term of geometry. So also this, you can see that this is become not just a character, it is a symbolic architecture encoding the fundamental patterns of transformation, and it captures all the duality, recursion, all the what would be studied in physics, the biology, even today's quantum mechanics. So it gives us an interconnected reality. So actually, I was thinking further that the natural language we speak, we describe in our dictionary, in our published papers, we use symbols, all different symbols. So this is sort of like leaves come out from us here. So now the language has a meaning to it. So it's sort of, can we study our language geometry? So language geometry. So we came out, we reflect nature, we have our own language. And then, so this is some idea observation. I continue to looking to the collaboration and also see if there is a way we can have a better understanding of sort of geometry of our mind. And I want to end over this slide here. And thank you so much. Certainly, I'm glad that I'm able to get this connected. I worked with the technical support on the ship. They get me connected. Initially, I was trying to have this phone, see if I'm able to. It worked initially, but it's too small. And I got my laptop worked. So happy here. Thank you so much.
Thank you so much, Matthew. So I think if this, let's say, symposium shows something, that there's an absolute lot of work to do. And I'm very grateful that we have a Western perspective, that you always bring a kind of Eastern perspective. Before we go to the rounds, I would like to show from my side a few slides. And this is something when you go to, say, cosine and sine